An object is dropped from an airplane. During the first second, the object falls 4.9 meters. During the second second, it falls 14.7 meters. During the third second, 24.5 meters. And during the fourth second, 34.3 meters. So if this pattern continues, how far will the object fall during this 10th second? So let's go ahead and write down the first couple of terms in this sequence to see if we can find the pattern. So the first second, it says it falls 4.9. The second second, 14.7. Then 24.5. And then 34.3. So it's important to note that when we say it falls 34.3 meters, that's not the total distance it has fallen. That's only how far it fell during that fourth second. So when it asks us how far did it fall during the 10th second, we're really being asked to find the 10th term. In other words, we're trying to find a sub 10. So first of all, what's the pattern here? How do we get from one term to the next? Is there a consistent pattern? And it does appear to be consistent in this case. It looks like we're adding 9.8 repetitively. So adding 9.8 over and over gets us the next term in the sequence. And this is going to tell us, remember, two things. One, we have an arithmetic sequence of numbers because we're adding the same number each time. And that number that we're adding is called the common difference. So D is equal to 9.8. So if you want to rely on your general formula for an arithmetic sequence, you certainly can. In this case, A sub n is equal to my first term, which is 4.9, plus n minus 1 times D, and D is 9.8. So that's one way to generate the formula for this sequence of numbers. And then we just have to go ahead and substitute in 10 for n, and that will get us the 10th term of our sequence. So 4.9 plus 10 minus 1 times 9.8. And our 10th term appears to be 93.1. And let's put some units on that. That's going to be meters. So this object will fall 93.1 meters during the 10th second. But let me pause and just remind you, you do not have to be a person that utilizes this general formula here that I've highlighted in yellow. You could be a person instead that recognizes that if we're subtracting, or in this case, adding 9.8 over and over again, then we would start off with 9.8n. And then you could just ask yourself, what am I going to add or subtract? How am I going to adjust my formula to make it work so that my first term is 4.9? In other words, I want to plug in 1 for n, so 9.8 times 1. And then what number do I either need to add or subtract here so that I get 4.9 as my first term? And in this case, you can see we actually need to subtract. We would need to subtract 4.9 to make this work. So this tells me that my general formula would be 9.8n minus 4.9. And this is a great general formula. If this works for you better than using the previous one that I have highlighted in yellow, that's completely fine, because now you're going to go ahead and plug 10 into your general formula, 9.8 times 10 minus 4.9, and you're going to quickly realize that you get the same answer. It's still 93.1 meters. Now for part B, it asks us to find the total distance that the object will fall. So this is a bit different because total distance in this case means that we're actually trying to find a sum. In other words, we want to take the distance that the object fell in the first second, which was 4.9, add it to the distance that the object fell in the second second, plus the distance that the object fell in the third second, and so on. And we want to continue doing that for the first 10 seconds. So we've already established that it was an arithmetic relationship. So once we know that, we have a nice formula for the sum of the terms in an arithmetic sequence. So remember, that's the number of terms, n, times the first term plus the last term divided by 2. So in this case, we're summing up 10 terms. So n is equal to 10. My first term is 4.9. That was how far the object fell in the first second. Now my 10th term is how far it fell in the 10th second, and that's what we just figured out in part A. That's 93.1, all divided by 2. Go to your calculator, and it looks like we have a total distance of 490 meters. Total distance that this object fell in all of the first 10 seconds would be 490 meters.